Picture the night of January 7, 1610. A man in Padua points a tube of metal and curved lenses toward Jupiter, and for the first time in the history of our species, someone sees that another planet has moons of its own. That man is Galileo. That instrument depends on one single material bending light exactly the way he needs it to. Now take that material away. Not the telescope, not the tube, the substance itself. No glass. Ever. What happens to Galileo? What happens to everything he saw and everything that came after? The answer is far stranger and far more fragile than you would expect. Because here is the uncomfortable truth. Galileo did not invent the telescope. He did not even invent the idea of grinding lenses. He simply improved a toy that a Dutch spectacle maker had patented 1 year earlier. And that toy, and every idea built on top of it, traces back to a substance humans stumbled into by accident, thousands of years before anyone thought to look at the sky through it. So let's go back, way back, to around 3500 BCE in Mesopotamia, where the first true glass appears, not as a lens, but as a glaze on beads and pottery. The Roman writer Pliny the Elder later told a legend that Phoenician sailors, camping on a beach, propped their cooking pots on blocks of natron, and the heat fused the sand and soda together into a strange, shining puddle. It's a good story. It's probably not literally true, but it captures something real. Glass was not designed. It was found. Sand, ash, and fire combined by accident again and again until someone noticed the puddle could be shaped. For nearly 3,000 years after that, glass stayed decorative. Beads, vessels, small windows for the wealthy. Nobody was grinding it into precise curves to bend light on purpose. But here's what's fascinating. The Romans did notice something strange about glass. The philosopher Seneca, writing in the 1st century, described how a glass globe filled with water could make small, faint letters appear larger. He wasn't studying optics. He was describing a curiosity. Magnification existed already, sitting right there in a jug of water, and almost nobody thought to ask why. That question finally got asked seriously around the year 1021, when the scholar Ibn al-Haytham, working in Cairo, wrote his Book of Optics. He worked out how light travels in straight lines, how it refracts, how the eye actually perceives images, rather than simply projecting them out like earlier theories claimed. His work used polished crystal and glass segments to test how curved surfaces bend light. Ibn al-Haytham is often called the father of modern optics, and his research eventually crossed into Europe, where it landed in the hands of monks and craftsmen who had access to something he didn't have easy access to in the same abundance: cheap, moldable glass. But there's another layer to this, and it's the layer most people skip. Around 1286, in northern Italy, someone, possibly a glassblower in Pisa, possibly a monk, nobody knows for certain, figured out how to grind small glass discs into a shape that could be worn over the eyes to correct blurry vision. Eyeglasses. Suddenly, an entire population of aging scholars, monks, and merchants who had lost their close-up vision to age could keep reading and working. And that detail matters more than it sounds like it should, because it created something the ancient world never had: a functioning marketplace of skilled lens grinders, spread across ordinary workshops, not locked away in royal courts or scholarly elites. That marketplace is the part nobody talks about when they tell the story of the telescope. Because in 1608, in the Dutch city of Middelburg, a man named Hans Lippershey did not have a university position. He was not a court astronomer. He was a spectacle maker. An ordinary craftsman who ground lenses for eyeglasses every single day, and who, according to the story, noticed that 2 lenses held at the right distance apart made a distant church weather vane look closer. He filed a patent for a device he called a kiker, a looker. Word of it spread through Europe within months. By the following year, Galileo, who taught mathematics in Padua and desperately needed money and prestige, heard rumors of the Dutch device and built his own version from scratch, without ever seeing the original. He didn't just copy it. He improved the grinding, improved the magnification, and pointed it somewhere nobody else had bothered to point it, straight up. So what did he actually see? He saw that the moon was not a smooth, perfect sphere the way ancient philosophy insisted it had to be. It was covered in mountains and craters, rough and imperfect, just like the Earth. He saw that Jupiter had 4 small points of light orbiting it, changing position night after night, proving that not everything in the heavens circled the Earth. He saw that Venus went through phases like the moon, which only made sense if Venus orbited the sun. Each discovery chipped away at 1,000 years of accepted cosmology, and each one depended entirely on 2 curved pieces of glass, ground to a precision that required, more than anything else, a cheap, abundant, moldable material that ordinary craftsmen could shape by hand. So take that material away completely. What's left? Humans still had other transparent materials. Rock crystal, natural quartz, was known and prized since antiquity. Emperor Nero is said to have owned a pair of polished crystal lenses to help his eyesight. Ancient Assyrian sites have yielded a small, carefully ground piece of rock crystal, now known as the Nimrud lens, dating back nearly 3,000 years, possibly used as a magnifier or even a fire starter. So, in a world without glass, quartz becomes the fallback. But here's the problem nobody solves easily. Rock crystal is harder than glass and far more brittle, with internal fractures and impurities scattered unevenly through nearly every natural piece. Grinding it into a precise, symmetrical curve without shattering it takes enormously more time, skill, and waste than shaping molten glass, which can be poured, spun, and reground until it comes out clean. Quartz lenses existed, but they stayed rare, expensive, and limited to the wealthiest patrons, never spreading into ordinary workshops the way glass spectacles did in the 13th century. Polished metal offered another option. Mirrors made from bronze or speculum metal could focus light too. And centuries later, Isaac Newton would actually build his own telescope around a curved mirror instead of a lens, partly to avoid the color distortion glass lenses produced. But metal mirrors tarnish. They're heavy, difficult to cast without bubbles or warping, and require far more advanced metallurgy to produce a smooth enough surface than clay furnaces of the 13th century could reliably manage. So, without glass, optics doesn't vanish. But it slows down dramatically, and it stays locked inside the hands of a tiny elite, a handful of court scholars who could afford rare quartz or skilled metalworkers, rather than spreading through ordinary spectacle makers in Dutch market towns. There is no mass population of aging monks wearing corrective lenses in the 13th century, because no cheap material exists to make them from. There is no marketplace of craftsmen grinding lenses every day for a living, refining the technique through sheer repetition, the way Lippershey and his neighbors did for over 3 centuries before that fateful afternoon in 1608. And that's the part that flips the whole story. It's tempting to imagine that Galileo's genius alone would have found a way, that human curiosity always wins in the end. But that reading misses what actually happened. Galileo didn't invent optics. He inherited a fully mature craft tradition built by thousands of anonymous spectacle makers over 300 years, all working with one specific, humble material that happened to be cheap enough to fail with, again and again, until the failures taught the craftsman exactly how to succeed. Take that material away, and you don't just lose the telescope. You lose the entire, slow, invisible apprenticeship that made the telescope possible in the first place. And it doesn't stop with the sky. Here's the part that makes this whole counterfactual even bigger than one Italian mathematician and his telescope. The same cheap, moldable glass that let Lippershey grind spectacle lenses in Middelburg also let a Dutch draper named Antony van Leeuwenhoek, working decades later in Delft, grind tiny glass beads so precise they could magnify a drop of pond water nearly 300 times. Through those homemade lenses in 1676, he became the first human being to see single-celled organisms moving under his own hand. Around the same time, in England, Robert Hooke published Micrographia, a book built entirely around what compound glass lenses revealed about cork cells, insect eyes, and the structure of a flea. Without glass, there is no microscope either, which means no visible bacteria, no visible blood cells, no clear evidence that disease could be caused by something too small to see. The germ theory of disease, centuries later, leaned on the same accidental Mesopotamian puddle that gave Galileo his telescope. One material, bent two different ways, cracked open both the largest and the smallest scales of the universe within the same 70-year window. So what would a glassless version of that period actually look like? Slower, almost certainly. Patchier, definitely. Optics would likely have remained the property of a narrow circle, wealthy patrons in Persia, China, or Renaissance Italy, who could commission rock crystal lenses one at a time from specialized gem cutters, rather than an entire trade of ordinary craftsmen refining the technique through daily repetition and failure. Some version of magnification might still have emerged eventually, through polished quartz, through curved mirrors, through water-filled vessels like the ones Seneca described. Human curiosity is stubborn, but stubborn curiosity without a cheap, forgiving material to practice on tends to produce isolated flashes of insight, rather than a self-sustaining, spreading technology. A single brilliant optician grinding one rare rock crystal lens in a workshop is not the same thing as 300 years of anonymous Dutch spectacle makers quietly getting better, generation after generation, purely because glass was cheap enough to waste. Which means Galileo's moons of Jupiter were never just the product of one brilliant mind pointing a tube at the sky. They were the end result of a chain reaction that began accidentally, on a beach or in a Mesopotamian kiln, when sand and ash and fire fused together into something nobody had planned for. Take away that one accident, and the moons of Jupiter might have stayed invisible for another century, or two, or longer. Not because nobody was clever enough to look, but because nobody had the glass to look through.